Imagine for a second that you own this small independent toy store.
Okay, I'm picturing it.
Right. And it's the middle of August. It is absolutely sweltering outside, but you are sitting in your cramped back office, just sweating about something else entirely.
Let me guess, December?
Exactly. The holiday rush. You have to order inventory for December, and you have to make the call right now.
Ah, that's high stakes.
It really is. Because, I mean, if you order too little, you lose out on this massive potential profit when the shelves go bare. And worse, you lose customer loyalty.
Yeah, they'll just go buy from a big box store instead.
Right. But if you order too much, your back room is just like overflowing with unsold stock until next summer. It ties up all your cash flow and could literally bankrupt your business.
It's the classic supply chain nightmare, honestly.
So how do you predict the future? Do you just guess based on, like, a gut feeling? Do you just look at last year's receipts and arbitrarily add 10%?
I mean, a lot of people do exactly that, and it's terrifying.
It is. But today's deep dive actually holds the exact analytical tool for this specific problem. It's called the Forecast Sheet. And believe it or not, it's probably already sitting right there on your computer.
Just waiting to be used.
Exactly. So, welcome to Managing the Future. We are tailoring this deep dive specifically for you students tuning in from the Dr. Sam Pack College of Business at Tarleton State University.
And, of course, a warm welcome to all the working professionals joining us to, really level up those analytical skills.
For sure. Our mission today is a massive foundational deep dive into Module 24. That's Introduction to Data Analysis with Excel.
Which is pulled straight from the textbook Connect Master Management Information Systems by Richard Tedmon and Casey Wilhelm.
Right, the 2026 edition. And that toy store scenario we just talked about, it's the perfect place to start.
It really is, because that tension between holding too much inventory and stocking out, that's the reality for almost every product-based business out there.
Oh, totally.
But before we get to the really advanced tools like the forecast sheet, we actually need to look back for just a second at Module 23.
Right, the review of Excel fundamentals. We have to make sure the foundation is solid before we, start building skyscrapers.
Exactly. In that module, we laid down the basic architecture, right? The cells, rows, columns, pointers.
Yeah, how a cell is just the intersection of a column letter and a row number, like A1 or B4.
And we really hammered home the difference between relative and absolute referencing. I cannot stress enough how many young professionals trip up on this.
Oh, I've been there. You copy a formula down a row and suddenly all your numbers are just completely broken.
Right, because by default, Excel uses relative referencing. The spatial position shifts. But if you want a reference to stay locked on a specific cell, like, say, a fixed state sales tax rate.
You have to use absolute referencing. You just slap that $ symbol before the column letter and the row number.
Or, even better, you just leverage the F4 key shortcut.
The F4 key is an absolute lifesaver. We also went through basic functions like AutoSMIM, average, MIN, max, and the PMT function for calculating loan payments.
Right. So if Module 23 was about pouring the concrete foundation of a house, Module 24, our topic today, is where we wire the electricity.
I love that. We're installing the smart home tech today.
Exactly. We're taking static formulas and turning them into dynamic data analysis tools that actually drive high-level business decisions.
Okay, before we start wiring this smart home, I just wanted to quickly invite you to like, subscribe, follow, share, and drop a comment on today's deep dive.
It's definitely the best way to stay updated and, join the conversation with your fellow business students.
Absolutely. All right, let's jump straight into the deep end here. We need to talk about the sheer ubiquity of Excel across modern industries.
Yeah, its footprint is just staggering. A lot of people think Excel is just this isolated IT tool or like a digital calculator app.
Right, like it's just for accountants staring at balance sheets.
Exactly, but it's deeply embedded in the operational DNA of almost every business function. Take marketing, for instance.
People usually think marketing is all just graphic design and copywriting.
Right, but modern marketing teams use Excel constantly. They use it for rigorous quantitative analysis, tracking A/B test results, doing complex customer segmentation.
Wow, so not just budgeting.
Not at all. And sales teams rely on it for pipeline forecasting, calculating highly complex multi-tiered commissions, managing field inventory.
And obviously, accounting and finance use it constantly. That feels like its natural habitat.
Oh, without a doubt. It's the backbone for cash flow forecasting, tax planning, building intricate financial models, portfolio management. But what usually surprises students is its massive presence in medicine and the hard sciences.
Okay, let me stop you there because I would have completely assumed they'd be using highly specialized, regulated medical software, not, a Microsoft Office product.
Well, they do use specialized software, sure,
Yeah.
but Excel is still ubiquitous as this sort of translation layer.
What do you mean by translation layer?
Medical professionals use it constantly for tracking patients across different departments or managing clinical trial data. Scientists use it for environmental monitoring logs, running chemical analysis outputs, things like that.
But let me play devil's advocate for a second. With all the specialized multi-million-dollar software out there, and scientists use heavy-duty languages like Python or R, isn't Excel basically just a legacy tool at this point?
It's a super common objection, but it completely misses how businesses actually operate. You have to think of Excel as the ultimate Swiss Army knife of business.
Okay.
Yes, a data scientist might use Python to build a massive machine learning model, but when they have to explain that model's financial impact to the chief marketing officer...
They don't send them a Python script.
Exactly. They export it to Excel. It's the one language everyone in the C-suite actually speaks.
Oh, I see. It's the common denominator.
Right. It bridges that critical gap between raw, siloed data and actionable insights faster than almost anything else.
That reframes it perfectly.
Yeah.
Okay, so speaking of actionable insights, a massive part of that is being able to actually comprehend the data visually, which brings us to charts and color conventions.
Because staring at a grid of 10,000 raw numbers doesn't exactly scream insight. Our brains just aren't wired for it.
No, not at all. So the textbook defines three main chart types. First up, bar graphs or column charts.
Right. These are best for comparing multiple distinct items over a set period of time or side by side.
Like if I run a regional car dealership, a bar graph would be perfect for comparing total sales of sedans versus trucks versus SUVs for the month of May.
Exactly. The visual height of the bars lets the brain instantly rank them. Next, you have line graphs. These are the gold standard for showing changes occurring continuously over time.
So tracking my dealership's monthly revenue over 2 years.
Yes. The continuous line makes long-term trends and seasonal spikes instantly recognizable. And finally, we have pie charts.
Which people love to overuse, right?
Oh, they are heavily overused by amateurs. They should be strictly reserved for comparing parts of a unified whole, like breaking down your annual corporate budget by department.
But you can't just slap a chart on a spreadsheet and call it a day. The textbook mentions specific elements you have to include.
A chart without context is basically abstract art. It's useless. You need a clear, descriptive title, not just sales, but Q3 regional sedan sales.
Right, context is everything.
And acts as identifiers, explicitly stating what the X and Y axes measure. Plus, you usually want data labels showing the exact numeric entry over each data point.
So executives aren't just like mentally guessing where a bar lines up on the grid.
Exactly. And a legend to define what the colors or lines actually represent.
Speaking of colors, I always assumed you just picked whatever color scheme matched your company's brand, or just whatever looked nice.
Oh, no. That is a dangerous assumption.
Really? There are strict rules.
Very rigid conventions. If you violate them, you look like a total amateur in a boardroom. In finance, black indicates positive values, profits, credits. Red indicates negative values, deficits, losses.
So if my corporate brand logo is cherry red, I absolutely do not want my quarterly profit bars to be cherry red.
Never, because red universally means you have a major problem. And for safety or risk assessments, it's the traffic light system.
Green is safe, yellow is caution, red is danger.
Exactly. You do not want to mix those up when presenting a cybersecurity risk assessment.
I used to think using the wrong chart was just poor taste, like wearing a tuxedo to the beach.
Yeah.
But it's actually fundamentally the wrong instrument.
Totally.
Like if I want to show my toy store's monthly sales over 2 years, and I use a pie chart with 24 different slices just to make it look colorful.
You'd have 24 tiny overlapping slices that tell the viewer absolutely nothing about the passage of time. It would be completely unreadable.
A line graph is the only logical choice there. But of course, a perfectly formatted chart only matters if the underlying numbers are correct.
Which brings us to arguably the most vital part of data analysis, data cleansing and preparation.
Ah, yes. The tedious stuff. Garbage in, garbage out, right?
Exactly. If your underlying dataset is riddled with errors, your stunning chart is just beautifully visualizing a lie.
So what are we actually looking for when we clean data? Say I export a list of 5,000 customers from my CRM into Excel.
You're hunting for a few common structural issues. First, removing duplicates. Someone buys online and in-store, suddenly they exist twice and artificially inflate your customer count.
Oh, that makes sense.
Second, fixing inconsistent categorical data. One salesperson types widget A, another types WDGTA, a third types widget A.
And Excel sees those as three completely different products.
Exactly. Your pivot tables will be fractured. You also have to deal with missing values and extreme outliers. And finally, fixing insidious formatting issues, like hidden spaces.
I like to think of data cleansing like prepping ingredients in a commercial kitchen. You can't cook a Michelin star meal with unwashed vegetables straight from the farm.
That is a phenomenal analogy. You have to peel them, standardize the cuts, get your mise en place ready before the cooking even begins.
And Excel gives us the tools for that prep work. Find and replace for those inconsistent product names. Text to columns for when an imported file clumps a first name, last name, and email into one cell.
And crucial for business students, the trim function.
Oh, let's talk about trim. Because invisible formatting issues drive people insane. You have two identical-looking cells, but a lookup formula fails, and you just want to throw your laptop.
What you're experiencing there is the classic trailing space problem. External databases often bring along invisible ASCII space characters before or after the text.
So Excel reads the word apple and apple with a space at the end as two completely different things.
Yes, and your formulas will fail. To fix it, you just type equals trim, open parenthesis, select the cell, and close parenthesis. It automatically strips out all leading spaces, trailing spaces, and reduces any multiple spaces between words down to one.
It just sanitizes the text string. That is so elegant.
It really is.
Okay, so the data is pristine. But if I have 10,000 rows of clean data, it's still just a visual wall of gray text. How do I actually spot actionable anomalies without reading line by line?
That is where the immense power of conditional formatting comes in. It lets you establish logical rules that automatically change the background color or font of a cell if the data meets certain parameters.
Let's tie that back to our toy store hook. Say I have a clean database of my recurring customers' children's ages and another sheet with my warehouse inventory.
Okay, perfect. In the customer database, you could set a rule to color code the ages based on developmental toy categories.
Oh, nice.
You tell Excel, if the age is 0 to 3, highlight green. If 4 to 7, highlight blue. If 8 to 12, yellow. Instantly, your gray spreadsheet becomes a visual heat map.
So I can immediately see if my core customer base is aging out of toddler toys and into board games.
Yeah.
What about the inventory side?
You could set a rule to highlight a whole row in bold red if an item was purchased over 365 days ago, and the inventory quantity is greater than 0.
So it acts like an automated alarm system for dead stock that's tying up capital.
Exactly. It tells you exactly where to look so you can aggressively discount it.
It turns a static list into a dynamic dashboard. Okay, so our data is clean and visually highlighted. Next in the module is how we architect and refer to this data.
Right, moving beyond just saying, look at cell A1 through A1500.
The textbook introduces named ranges, structured referencing, and advanced dates. Why do I need to name a range? Isn't A1 to A1500 perfectly clear to the computer?
It's clear to the computer, but it's entirely opaque to the human trying to audit your work 6 months later.
Fair point.
Naming a range is essential for transparency. You convert a raw grid of cells into an official table object and assign it a meaningful name. This makes your ranges dynamic.
Dynamic how?
Well, if you write equals sum a1.a1500 and tomorrow someone adds 50 new rows of sales data, your formula is broken. It's ignoring those new rows.
Oh, I see. I'd have to manually update the coordinates every time.
Exactly. But if you convert it to a table named Sales Data 2026 and sum the table, any new rows are automatically swallowed up and included. Your formulas update without you touching them.
That prevents so many human errors in monthly reporting. And that leads directly into structured referencing. The syntax looks intimidating, though.
It changes the grammar of your formulas. Instead of abstract coordinates, you use the names of the tables and column headers.
So what does that look like in practice?
Looks like equals sum, open parenthesis, sales data 2026, open square bracket, revenue, close square bracket, close parenthesis.
Oh, wow. So anyone looking at my formula bar sees exactly what I'm doing in plain English. I'm summing the revenue column in the sales data table. It's basically self-documenting.
Exactly. It democratizes the logic of your model.
Now, speaking of highly structured data, we absolutely have to discuss advanced date functions. Excel is notoriously weird about how it handles dates.
It is, and there's a specific architectural reason for that. Excel doesn't see dates as words. It translates every date into a sequential serial number behind the scenes.
Right? I remember reading this. It starts counting from January 1st, 1900 as serial number 1. So today's date is just 40-something thousand days since then?
Precisely. And because they are just integers under the hood, you can add and subtract them mathematically.
The textbook highlights functions like date, datif, and crucially, network days.
Yes.
I want to pause and challenge network days for a second. If dates are just numbers, and I want to know how long a project took, why can't I just subtract the start date from the end date with a minus sign?
You could, and Excel would give you a number. But in business, that number would likely be dangerously misleading.
How so?
Let's walk through it. An employee starts a project on the 1st and finishes on the 14th. Standard subtraction says the project took 14 days.
Right.
But if 4 of those calendar days were Saturdays and Sundays, the employee only actually worked and billed for 10 days. Standard subtraction counts the weekends, which inflates apparent productivity.
So network days fixes that.
Exactly. It calculates only the working weekdays between 2 dates, automatically skipping weekends. You can even add custom company holidays for it to skip.
That's a massive distinction. If you use standard subtraction for an hourly contractor's pay, you'd overpay them for weekends they didn't work and drain the company's operating account.
You could literally trigger a payroll audit just by using a minus sign instead of network days.
Okay, message received. So our data is clean, organized in dynamic tables, and our dates are calculating true business days. Now we transition to actively asking our data logical questions.
Which brings us to logical functions. These are essentially binary true-false questions posed to the Excel engine. The foundational anchor here is the if function.
How does the internal logic of the if function actually operate?
Think of it like a toll booth operator on a highway. The operator has a rule, and depending on whether you meet it, they send you down one of 2 paths.
Okay, I like that visual.
The syntax has 3 arguments. First, the logical test the rule, like, is cell A1 greater than 100? Excel decides true or false. Second argument, value if true, what should Excel do if yes? Maybe apply a 10% discount.
And the third argument is the value if false, what to do if the answer is no, apply a 0% discount.
Exactly. It's a branching decision tree. But the textbook also introduces helper functions like AND, OR, NOT, and IFER.
Why do we need those if AMP already makes decisions?
Because the real business world is rarely black and white. Businesses make decisions based on complex intercepting criteria. You have to nest these functions together.
The textbook gives a really realistic example of calculating a commission sales force bonus by nesting AND inside an IF function.
Let's break that down. Imagine you manage a sales team. The quarterly bonus rule is they only get the bonus IF, they exceed their revenue target, and they exceed their new customer acquisition target.
They must achieve both. Gross revenue, but no new customers. Nothing. New customers, but miss revenue. Nothing.
Right. Both conditions must be true simultaneously. To write that in Excel, you start with the if function. But for your logical test, you insert the AND function.
So equals IF, open parenthesis, AND, open parenthesis. First test is actual sales greater than target sales, comma. Second test is actual customers greater than target customers. Close the AND parenthesis.
You've built a multi-lock door. Now finish the IF statement, comma. Value if true. Multiply sales by the 5% bonus rate, comma. Value if false, 0. Close final parenthesis.
So Excel runs both tests inside the AND gate and then funnels the result to the IF gate. That makes so much sense when you explain the logic gates. You're building an automated rule engine.
Evaluating those conditions row by row for 50 salespeople is incredibly powerful.
But wait, what if you're not managing 50 salespeople? What if you're analyzing 10 million rows of point-of-sale data globally and the CEO wants a high-level summary right now?
When you hit that scale, you stop writing individual formulas and you deploy a pivot table.
Okay, we arrive at the pivot table.
It is arguably the single most important analytical tool a business student can master. It's a dynamic engine designed to rapidly summarize, cross-tabulate, and aggregate massive data sets without writing a single formula.
Walk me through the mechanics of cross-tabulation and aggregation.
You start with your clean source data formatted as a table. You insert a pivot table, and Excel opens a blank canvas with a field list pane on the right.
That list has all my column headers, right? Like date, region, product, revenue.
Exactly. And below that list are 4 quadrants: filters, columns, rows, and values.
What happens when I drag things around?
This is where aggregation happens. Drag the region field into the rows quadrant. Excel scans your 10 million rows, identifies every unique region, say North America, Europe, Asia, and creates a clean summary list of just those 3 on the canvas.
It collapses millions of duplicates into a single unique instance. But where do the numbers come in?
You take a quantitative field, like revenue, and drag it into the values quadrant. Excel instantly sums up all transactions in North America and displays the total. Same for Europe and Asia.
2 clicks and 10 million rows become a 3-line executive summary. That is astonishingly fast. People always compare pivot tables to a Rubik's Cube, twisting data to look at different sides. But that analogy feels wrong based on what you're saying.
You're exactly right to challenge that. A Rubik's Cube maintains the exact same number of visible squares. A pivot table isn't just moving pieces, it's mathematically crushing them together.
It's more like taking a massive pile of 10 million grocery receipts, throwing them in a magic sorting machine, and getting a single page showing revenue for the produce department versus the meat department.
Exactly. It aggregates.
The textbook uses an example of a retail company tracking cookie sales across different states. How does a pivot table solve that?
You drag the cookie type field into rows. Now you have a list of cookies down the left. Drag state into columns. Now you have states across the top, creating a matrix.
And then drag sales amount into values. Instantly, I can look at the Thin Mints row, read across to the Florida column, and see the exact aggregated total.
Precisely. And if the CEO wants to see it grouped by state first, you just drag state above cookie type in the rows quadrant, and the whole matrix rebuilds itself instantly.
It's basically analytical magic, but there's always the pivot tables rely on all your data being neatly organized in one unified table.
Which is almost never the case in the real corporate world.
Right. What if I have employee IDs and monthly sales in one spreadsheet, but their actual names and regions are locked away in an HR workbook? A pivot table can't cross-tabulate data. It can't see.
That specific pain point is exactly why Section 7 exists. The lookup family of functions. When data is fractured across different tabs or workbooks, lookup functions are the bridge you build to bring them together.
Let's start with the grandfather of them all, the one everyone is told to put on their resume, VLOOKUP. How does it conceptually operate?
VLOOKUP stands for vertical lookup. It searches down vertical columns. Conceptually, it acts exactly like a human looking up a number in a physical, old-school telephone book.
Okay, I'm the VLOOKUP function. What are my instructions?
It needs 4 arguments. First, the lookup value, the name you're trying to find in the phone book. In our corporate example, it's the unique employee ID.
Okay.
Second, the table array, the actual phone book itself. The range in the HR workbook containing the IDs and details. Third, the column index number.
What's that?
Once you find the ID in the phone book, how many columns over should you count to find the data you want to bring back? If ID is column 1 and name is column 2, your index number is 2.
And the fourth argument is that weird true-false toggle, right?
Yes, the range lookup. You almost always want to enter false here, which forces Excel to find an exact match. If you type true, it looks for an approximate match.
Which would be catastrophic for matching distinct employee records.
Yeah.
Okay, so VLOOKUP scans down the leftmost column, finds ID 405, counts over to column 2, grabs Sarah Smith, and pulls it back. Sounds incredibly useful.
It is.
But the textbook spends significant time on XLOOKUP and the combination of index and match. Why do we need those if VLOOKUP works so well?
Because VLOOKUP has a massive, fatal architectural flaw. It can only search the absolute leftmost column of your table array, and it can only return data located to the right of that search column.
Wait, really? So if my HR spreadsheet has the employee name in column A, but their unique ID is in column C, VLOOKUP cannot use the ID in column C to pull the name in column A.
It absolutely cannot. It cannot look left.
That seems like a massive design flaw. If a vendor report has the key identifier in the middle of the sheet, VLOOKUP is basically useless unless I physically cut and paste columns around, which risks destroying data integrity.
Exactly. And that's why power users develop the index and match combination to bypass the flaw. They are 2 separate functions nested together.
How did that work?
MATCH is purely a location scout. You give it the employee ID and tell it which single column to search. It scans it and just returns the row number where it found the ID, say row 42.
Okay, MTCH just gives me a coordinate. How do I get the data?
You feed that row number into the index function. Index is an extraction tool. You point it at the column containing the names and tell it to extract whatever is in row 42.
Ah. Because you define the search column and the return column completely separately, they're decoupled. It doesn't matter if the return column is to the left, right, or on another planet.
Precisely. It breaks the directional handcuffs of VLOOKUP. Now, Microsoft recently released XLOOKUP to build that flexibility into a single, easy-to-use syntax. It can search in any direction and defaults to an exact match.
Okay, let me push back on the curriculum then. If XLOOKUP is the modern upgrade and index match is superior, why on earth do business students still need to learn VLOOKUP? Shouldn't we just banish it to the history books?
It's a fair question, but it ignores the reality of corporate infrastructure. You have to learn VLOOKUP because of the crushing weight of legacy systems.
Oh, meaning the older spreadsheets.
Exactly. When you enter the workforce, you're rarely building pristine models from scratch. You're inheriting massive financial models built 10 years ago by your predecessors.
And they built everything using VLOOKUPs.
There are literally hundreds of millions of mission-critical spreadsheets running right now, structurally bound together by VLOOKUPs. If you don't understand how it operates, you won't know how to read them, update them safely, or troubleshoot them when they break.
That makes total sense. You can't be a master mechanic if you only know how to work on brand new EVs. You still have to know how to fix a traditional combustion engine.
Exactly.
Okay, moving beyond looking up historical data, let's explore Section 8, predicting the future using what-if analysis. Up until now, we've summarized what did happen. What-if analysis explores what could happen.
It's a profound shift. It transforms Excel from a passive historical ledger into an active, predictive modeling sandbox.
The module covers 3 tools for this: Beta Tables, Scenario Manager, and GoalSeek. Break down the differences for me.
It depends on how many variables you want to manipulate. Let's start with beta tables. They're designed to analyze the impact of changing either 1 or 2 variables simultaneously.
Give me a real-world application for a data table.
Imagine you're an analyst deciding whether to transition a delivery fleet from gas-powered vans to electric vehicles. Your formula calculates total profit margin.
Okay.
The 2 volatile variables are the fluctuating cost of diesel fuel and commercial electricity rates. A 2-variable data table lets you set up a matrix. Fuel costs down the side, electricity costs across the top.
And Excel automatically runs the profit formula for every intersecting combination of those 2 prices.
Instantly. It gives you a comprehensive visual map of your risk exposure across all possible market conditions.
That's incredible for risk management. But what if I have more than 2 variables? What if I'm modeling something with 5 or 6 moving parts?
Then you graduate to the Scenario Manager. Data tables are limited to 2 variables because they display on a flat 2D grid. Scenario Manager can handle up to 32 changing variables at once.
Like creating a best case, worst case, and most likely case scenario for a forecast.
Exactly. If forecasting real estate profitability, your worst case might simultaneously increase interest rates, increase lumber costs, and decrease the final sale price. You save that configuration.
And with Scenario Manager, you can just toggle between these radically different macro environments with a single click.
Yep, and Excel recalculates the entire model instantly, generating a side-by-side summary report.
So those 2 are exploratory. You change inputs and see the result. What about the 3rd tool, GoalSeek? How does that flip the paradigm?
GoalSeek is a targeted, iterative solver. It works completely backward. Instead of changing inputs to see the answer, you already know the exact answer. You want your goal, and you command Excel to figure out what input is mathematically required to achieve it.
Okay, let me build a concrete business scenario for this one. Let's go back to my regional car dealership. We're in the last week of the month. My accountant says we need a very specific target profit to avoid a loss for the quarter.
Okay, what's the number?
Let's say exactly $50,000. That's my non-negotiable goal. How does GoalSeek find my path there?
You open the GoalSeek dialog box, which asks for 3 parameters. First, set cell. You select the cell containing your total profit formula. Second, to value, you manually type in 50,000.
And a 3rd.
By changing cell, you select a single variable input cell you have control over. Let's say you select the number of cars sold cell.
So I hit calculate. What is Excel actually doing mathematically under the hood?
It runs an iterative algorithm. It rapidly guesses thousands of different numbers for cars sold, plugging them into your model, seeing if the profit is too high or too low, adjusting and recalculating over and over in a fraction of a second.
Until it converges on the exact answer.
Right. It might tell you that to hit exactly $50,000, you must sell exactly 43.7 cars.
Which means I need to sell 44 cars to survive. and I could run it again and tell it to change my advertising budget cell instead to see how much I need to slash my ad spend to hit the same goal without selling more cars.
Precisely. It completely eliminates the exhausting manual trial and error process of plugging arbitrary numbers in for an hour.
So what if analysis is fantastic for exploring possibilities manually? But what if we want Excel to look purely at historical data, find the mathematical patterns, and draw the most statistically probable future for us?
Which loops us right back to the high-stakes hook at the very start of our deep dive, the Forecast Sheet function.
Back to the sweltering back office in the toy store. I need to order for December. How do I use the tool?
You must have clean, chronological, historical data, time series data. You pull your monthly sales volume data from the past 3 years.
Okay, dates in one column, sales volume in the next. What's the execution?
You highlight the data, navigate to the Data tab, and click Forecast Sheet. Excel instantly opens a preview window featuring a line chart. The blue line is your historical data, and an orange line stretches into the future.
But is it just taking a lazy average of my past 3 years and drawing a simplistic straight line into the future? Because business doesn't work in straight lines.
No, it doesn't. Excel's forecasting engine uses advanced mathematical algorithms, specifically exponential smoothing, or ETS, to detect underlying patterns. And you have to configure 2 crucial options. First is the confidence interval.
What does that mean in plain English?
It's a statistical expression of certainty, usually set between 90 and 95%. Excel generates shaded upper and lower bounds, a cone of probability around that predictive orange line.
So it's saying, we are 95% confident your actual future sales will fall somewhere inside this shaded range.
Exactly. It visualizes your margin of error.
That gives a small business owner a best case and worst case mathematical boundary for inventory orders.
And the second critical feature is seasonality. The ETS algorithm mathematically searches your historical data for recurring cyclical variances.
So it recognizes that every single December sales violently spiked, and every January they violently dropped.
Yes. It calculates the periodicity of that cycle and builds that exact seasonal curve into the future forecast.
That takes the raw emotion and terrifying guesswork completely out of supply chain ordering. You have a statistically sound prediction.
Exactly.
Now, for our final exploration, we're looking at the heavyweights of the Excel ecosystem. The textbook notes that when standard Excel hits a wall, we turn to Excel Power Tools and Microsoft Copilot.
This is the transition from basic data analysis into true business intelligence architecture. Standard Excel is limited by its physical grid, roughly 1.04 million rows.
Which sounds like a lot until you're a regional retail chain generating 5 million point-of-sale transactions a month.
Right, standard Excel will literally crash. To handle that, Microsoft built 3 specialized add-ins: Power Query, Power Pivot, and Power BI.
Let's break those down. What does Power Query do?
Power Query is your data extraction and transformation engine, an ETL pipeline. It connects to external data sources like a massive corporate SQL database, extracts the data, and lets you clean it.
But wait, can't I just clean data manually with find and replace and triom like we talked about earlier? Why do I need Power Query?
Because Power Query makes it automated and repeatable. When you clean data manually, you have to do it again every single month. Power Query records every cleaning step as a sequential script.
Oh, wow.
Next month, when new raw data hits the server, you just click Refresh. It runs the new data through the exact same steps in seconds. It completely eliminates repetitive manual labor.
Okay, massive time saver.
Yeah.
So Power Query cleans and loads the data. What about when the data is too massive for the grid? That's Power Pivot.
Yes. Power Pivot is where you build robust relational data models. Instead of forcing all your data onto one massive tab using millions of VLOOKUPs, which will crash your memory, Power Pivot operates behind the scenes in a highly compressed memory state.
How do you connect tables without VLOOKUPs then?
You build a relational model. You visually draw connecting lines between tables based on common identifying columns, primary and foreign keys.
Like linking the employee ID column in the sales table to the employee ID column in the HR table.
Exactly. Once linked in the model, you can build a single pivot table that pulls fields from both tables as if they were one. Plus, Power Pivot lets you write incredibly advanced DAX formulas.
DAX, data analysis expressions. How is that different from a standard formula?
Standard formulas calculate across physical cells on a grid. DAX calculates across entire columns and relational structures inside the memory model. It can handle calculations across 30 million records dynamically that standard Excel simply cannot compute.
Okay, so Power Query cleans, Power Pivot models.
Yeah.
Where does Power BI fit into this trinity?
Power BI is the presentation layer. It's a separate application and cloud service where all that modeled data becomes a personalized, highly interactive dashboard for business users.
So not just static charts on a PowerPoint slide.
Not at all. An executive can open a Power BI dashboard on their tablet, look at a global map, tap on the state of Texas, and instantly every other chart and table on the dashboard dynamically filters to show only Texas data.
It takes data from a static grid and transforms it into an interactive software application.
Exactly. It empowers non-technical executives to explore complex data intuitively.
The evolution of these tools is staggering. But speaking of evolution, we have to talk about Microsoft Copilot, the new AI integrated directly into Excel.
Copilot is a fundamental paradigm shift. It integrates large language model AI into the spreadsheet. Instead of navigating menus or writing complex syntax, you just highlight a data range, open a chat pane, and type a request in plain English.
Like, show me a chart of the top 5 performing salespeople in the Northeast region.
Yes, and Copilot will analyze the dataset, instantly generate the chart, and insert it. But it also auto-completes complex nested formulas, identifies hidden statistical trends, and even writes narrative summaries of what the data implies.
Okay, this is where I really need to push back hard, both on the technology and the curriculum itself.
Go for it.
If Copilot can just look at my raw data, understand plain English, write the perfect XLOOKUP formula, and draw the chart, does a modern business student even need to learn a single thing we just talked about for the last hour?
I hear this all the time.
Why spend weeks studying the syntax of index match or conditional formatting? Why not just skip it and let the AI do the heavy lifting?
It's arguably the defining question of business education right now, and I will push back against that premise with extreme prejudice. Copilot is a phenomenal assistant, but it is absolutely not a replacement for domain expertise.
The textbook explicitly warns about this, right?
Yes.
Yeah.
It says, always double-check the results and formulas suggested by the AI tool to ensure accuracy.
Because AI hallucinates. It makes things up confidently.
Precisely. And an AI hallucination in a spreadsheet doesn't look like a glitch. It looks like a perfectly formatted, highly plausible formula that just happens to be mathematically wrong.
That's terrifying.
Let's return to the NETWORKDAYS example. You ask Copilot to calculate project times for contractors. The AI, trying to be efficient, writes a formula that simply subtracts the start date from the end date using a minus sign. It confidently presents you with a column of numbers.
And if I skipped Module 23 and 24, I look at those numbers, assume the AI is infallible, and push them to payroll.
Yes. And you overpay contractors by thousands of dollars, draining capital. Or you underpay employees, violating labor laws and exposing the company to a massive lawsuit.
Wow.
If you don't understand the fundamental mechanics of relative referencing or the logic dates of an IF statement, you will not know if the AI is handing you a brilliant insight or a catastrophic error.
That is such a necessary reality check. You cannot advocate your intellectual responsibility to a chatbot. You have to be the expert capable of auditing the machine's logic. Well, on that slightly terrifying but highly empowering note, that brings us to the end of an incredibly comprehensive module. Thank you so much for bringing your deep expertise to this exploration.
It was an absolute pleasure unpacking all of this complexity with you.
Before you go, we want to invite you one more time to like, subscribe, follow, share, and leave a comment. Engaging really helps us, and leaving a comment is actually the perfect way to participate in today's final discussion question.
Yes. Here's the question we want you to ponder. Think about a business you currently work for, or maybe a startup you want to launch. How could you specifically employ a what-if analysis tool like Scenario Manager or GoalSeek to solve a major operational problem or predict a critical future outcome for that specific business?
Don't just name the tool. Drop your detailed, specific business scenario in the comments. I honestly cannot wait to read the scenarios you all come up with. The application is where the real learning happens.
Absolutely.
And as for what is next on our syllabus, you have now mastered the mechanics of the ultimate spreadsheet tool. But what happens when your data is too massive, too complex, and too unstructured to fit into a grid at all? Next time, we are unlocking a whole new level of technical capability in Module 24. Introduction to Data Analysis with Python Part 1.
Trust us, you will not want to miss the leap into programming.
So until then, keep your raw data impeccably clean, trust your rigorously tested insights, but always, always verify your AI.